All right, let's get started with 4.2, trig functions on the unit circle. So we're going to start with this. This is going to be our unit circle, and we really want to be comfortable with this circle with a radius of 1 in each direction. So 1 what? 1 centimeter, 1 inch, 1, we're not really sure. Just 1 unit, right? We don't have an actual type of unit. We're just going to call it 1 unit. That's why we call it a unit circle. It has a radius of 1. If we remember our circle formula, x squared plus y squared equals the radius squared. The radius squared here is 1, so the radius is just 1. So this is our unit circle. Anytime we refer to the unit circle, we're drawing this circle. Okay, and notice a couple important points. It hits 1, 0, 0, 1, negative 1, 0, and 0, negative 1. And so if we take this circle and we move around it, and we start moving a certain amount of degrees or radians in here, we're going to slide along the edge of this circle, right? So the radius is always going to be 1, and what we're going to be able to figure out is what are the x and the y values as we move around this circle. All right? So remember, positive is going counterclockwise, negative degrees, negative angles are going counterclockwise. And so with that, let's introduce our trig functions. So sine, cosine, cosecant, cosine and secant, and tangent and cotangent. So these are flips of each other. Sine is the flip of cosecant, and sine is defined as your y value. If you're on the unit circle, sine is the y value. Okay? Cosine is the x value. Sine alphabetically comes after cosine. Y comes after x. That's how you can remember that. Cosecant is the flip of sine. Secant is the flip of cosine. So when you flip them, you change the letters that you start with also. So starting with the S starts with the C. Starting with the C starts with the S. When you flip them over, instead of x, you get 1 over x. Little reminder here, you can't have 0 in the denominators. And then we have these other values here. So tangent, T-A-N, we're going to define as y over x, whatever the y value is, divided by the x. And cotangent then is x over the y. Again, can't have 0 in the denominator. All right, so here's the unit circle with a whole bunch of points added onto it. I would highly recommend pausing this video and getting this down. You're definitely going to need this. You will want to have this whole thing memorized by the end of the chapter. All right? Looks daunting to start, but gets easier. Let's take a look at some things. So these are our angles. It's degrees and radians. So we start with 0 degrees and 0 radians. And I'm just going to look at the angles to start. So here's our important angles: 0, 30, 45, 60, and 90. Those match up with 0 radians, pi over 6 radians, pi over 4, pi over 3, and pi over 2. So just looking at the first quadrant, if we have those angles, when we move to the second quadrant, we actually have the exact same angles if we start up from here, right? So 30 degrees up from 180 is 150, or going the other way, 30 more degrees is 120. So we're really just going in increments of 30, 45, and 60 to end up with the same angles in quadrants 2, 3, and 4. If I went negative, 360 minus 30 gets me to 330, right? If we're spinning this direction, it's negative. And so these are the radian values that match up with all of these. All right, so once we work with these are going to start being pretty familiar angles. All right, so as we look here, the x value on the unit circle that matches up with 30 degrees is root 3 over 2. The y value that matches up with 30 degrees is 1 over 2. Notice that if we switch to the other side, the 150 degrees, it's the exact same numbers, but just a negative, and that's easy to remember because in quadrant 2, x's are negatives. As we go up here, I'm going to skip 45 for a second, go to 60. Notice that 60 and 30 are the exact same values, just switched. Root 3 over 2, root 3 over 2. 1 half, 1 half. Notice if I go to quadrants 2 and 3 and 4, those numbers start to repeat themselves. All right, so you see the patterns here. And then 45s are all the same. These multiples of 45s are all going to be root 2 over 2 and root 2 over 2. It's just a matter of figuring out where the negative should be based on which quadrant you're in. And that's all the unit circle there. So get that down, pause the video, get the whole thing down, and you're going to want this in your notes for now. Eventually you're going to have this whole chart memorized. All right, so let's take a look at some example problems here. let's find the 6 trig functions of each real number. So I'm going to write them out here. Sine, cosecant, cosine, and secant, tangent, and cotangent, and let's make ourselves a little chart here so we don't have to rewrite this 4 times for all of these. All right, so we'll start with pi over 6. All right, pi over 6, I'm going to jump back over here. Pi over 6 is right here. My y value is 1/2. Sine is the y value, so sine is 1/2. If I flip that over, I get 2. The cosine is the x value, so that's √3 over 2. And if I flip that over, I get 2 over √3. Can't have 2 over √3 though, so let's clean this up. 2 over √3, got to multiply top and bottom by √3, so we would end up with 2 √3 over 3. 2 √3 over 3. All right, so tangent here, if we divide these two things, it's going to be sine divided by cosine, or y over x. In this situation, the 2's cancel out, and we have 1 over √3. If we were to clean that up, we end up with √3 over 3. So tangent is √3 over 3. If we were to flip this over, I'm going to go back to the beginning part when it was 1 over √3. If we flip that over, we would just have √3. All right? So let me go ahead and put in the answers for the rest of them. And we would end up getting them the exact same way. All right, so the sine of 5 pi over 4 on this one is going to be negative √2 over 2. Sorry, this is 5 pi over 4. So remember, these are the angles. If you have that angle, what's the y value? The y value is √2 over 2 with a negative. So 5 pi over 4, we're going down here now, and so we're using these values. All right, so we see the y value, negative √2 over 2, and the x value was also negative √2 over 2. If we flip these over, flipping them over, you're going to end up with just negative √2. Okay, and then for our tangent, we're going to get 1. Flip that over, we get 1 because when you divide these two things, they're exactly the same. So if you divide them, you get 1. All right, how about t is 0, an angle of 0? Let's do these out. For our angle 0, then we've got 1 comma 0. So our y value is 0 and our x value is 1. Flip 0 over. Can't do that. That's undefined. Flip 1 over, you get 1. Tangent is 0 divided by 1, which is just 0. Flip that over, can't do it, so the cotangent would be undefined. And lastly, let's take a look at pi. At pi over here, we've got negative 1 comma 0. So our y value again is 0 and negative 1. So same thing, undefined. If we flip negative 1 over, we get negative 1. If we have 0 over negative 1, we get 0. Flip it over, you're undefined. Your turn. See if you can do all 6 of those. Oh, nope, just 3 of them. Just sine, cosine, and tangent for 11 pi over 6. All right, we're going to do the same thing. 6 trig functions for negative pi over 3. So negative pi over 3. So I'm going to flip back here. Look at our unit circle. So pi over 3 is 60 degrees. But now I want to go negative. So negative 60 degrees is going to get us over here at 300 degrees, which is 1/2 for x and negative √3 over 2 for y. So let's put this in. So sine of negative pi over 3 is negative √3 over 2, which means that the cosecant of negative pi over 3 is the flip of that, and we've already figured out that that's 2 √3 over 3. All right, let's grab the cosine. What was the x value? The x value was 1/2. which means that the secant of negative pi over 3 is going to be 2. And then we're going to divide here to get our tangents. Tangent of negative pi over 3 is going to be negative root 3 over 2, whatever the sine is, divided by whatever the cosine is. Cancel your 2's and you get negative root 3. Cotangent is the flip of that. So you're going to get negative 1 over root 3. Can't leave it like that. Let's clean it up. So you'll get negative root 3 over 3. Your turn. Tell me this exact same thing, all 6 of them, for negative pi over 2. All right, so quickly let's talk about the domain and the range. All right, so domain is what can we plug in for the angle. All right, what angles can we plug in? We can plug in any angle we want. We can go positive, we can go negative. All right, so that's going to be all real numbers. But the range is the output, and the range for sine has to be between negative 1 and 1, because the most y value you could get, I'm going to say here and here, the highest and lowest we could ever be on the unit circle is going to be 1 and negative 1, because that's the radius. We can't be farther from the origin than that. That's how long the radius of the circle is. And so the same thing works for the range, the output of cosine, because cosine is x. What's the biggest x you could get? The biggest x you could get is 1. All right, so sine and cosine are always going to be in between or equal to negative 1 and 1. All right, now let's take a look at some properties here. If I go up 30 degrees, I'm going to have an x value of root 3 over 2. If I go down the same way but opposite direction, negative 30 degrees, take a look at what my x value is going to be. It should be exactly the same because we're just the same distance to the right of the y-axis. So my x value here is also going to be root 3 over 2, comma. Down here we're at negative 1/2. Up here we're at positive 1/2. All right? So cosine of a negative degree is going to get you the exact same thing as going in the positive direction. Cosine, if you spin to the positive or spin to the negative, you'll get the same answer. The x values are the same. Whereas sine, take a look at sine, if we go positive it's 1/2, but if we spin negative direction, we're going to get negative 1/2. So sine of a negative direction will be the negative whatever you would get if you went in the positive direction. And that's also going to be true of tangent. All right, so keep that in your notes. Remember that. That's going to come into play in future sections and chapters. All right, so example 3, just a couple examples here, and all these are, A and B, are just saying that if you go around the circle once, that's equal to 2 pi. And that just gets you back where you started. So 13 pi over 6 is the same as saying 12 pi plus 1 pi all over 6. 12 pi over 6 is 2 pi. So we can get rid of that. We're back to where we started. So really, we're just looking at pi over 6. What's the sine of pi over 6? The answer is 1/2. Same thing for B. Going around negative 4 pi is the same as going around twice, but actually, sorry, it would be negative twice, back where we started, and then it's a pi over 2 that's left over. So really, we're just doing the cosine of pi over 2, which is 0. And lastly here, if we know that sine of t is 4/5, what's the sine of negative t? Go back to our last piece of information. We're going to throw a negative in the front. So if our answer before was positive 4/5, now our answer is going to be negative 4/5. All right, so use the same thinking here. Tell me what the answer is for cosine of 7 pi over 3. All right, last thing here is just, can we do these on our calculator? Let me bring up the calculator. Make sure we can all do it together. Where's my calculator? There we are. All right, so we need to be able to do sine of 2 pi over 3. First things first, we need to be in radians because this is not a degree measure, it's a radian. So where we find that is in the mode. So I click mode. Right here, radian is highlighted, so I'm good to go. If it wasn't, I could go down and change it if I wanted degrees or if I wanted radians. Second quit brings me back to the screen, and let's do the sine of 2 pi over 3. I hit sine first, 2 pi over 3, and I hit enter, and boom, there's my answer, 0.866. We can do the cotangent of 1/5. All right, cotangent is a little tricky. Let me move this so we can see it. Cotangent is the flip of tangent. So we're going to do tangent and then flip it over. Flipping it over is the same as saying to the -1. All right, so let's do tangent of 1.5. And that's 14, but we want to do the reciprocal of that, 1 over that, and so we get 0.0709, which is the same as given here. So up to you. See if you can figure out how to do cosecant in your calculator. 4 decimal places here. Be accurate. Give me 4 decimal places. And that's it. That's all there is for 4.2. Questions, we'll go over them in class.